E-waste is the fastest growing form of waste. With technology changing fast and the increasing difficulty of recycling and reusing components, electronics often end up in the landfill.
Not only does this reduce the raw material resources left for future electronics, but it releases toxic metals into the soil.
Current solutions for e-waste are not enough, leading to loss of valuable materials, pollution to the environment, and low amounts of waste actually being recycled. This reveals a clear need for a new solution.
Disposable vapes reach the end of their life because they run out of vape juice, not because their battery stops working. The lithium-ion battery in vapes can still be reused.
According to a study by the U.S. Public Interest Research Group in 2023, 5.7 vapes are thrown out every second in America. This is enough lithium over 1 year to make over 6,700 Tesla Model X batteries. This number will only be increasing as the e-cigarette industry is projected to make over $10 billion in revenue by 2027.
As we look for a solution, we decided to focus on the excessive amount of lithium batteries that are destined for the landfill.
In order to come up with an effective solution, we compiled a list of requirements and criteria to better address the issue and the needs of potential stakeholders.
Our most important requirement is safety. Our product must meet all relevant safety criteria. Another requirement is reusability. Our product must include used parts or have parts that can be reused continually.
Some criteria we considered when selecting our final solution included a product that was able to be widely used, had a long lifespan, and yet was achievable at a low cost.
Power storage is also a growing problem. With renewable energy such as solar and wind being intermittent, it's impossible to rely on them independently.
Finding a more available way to store power so we can rely even more on renewable energy is essential.
While lithium batteries work well for home solar applications, their high cost makes them inaccessible for families.
We were able to address both of these issues using the vapes. By reusing these cells in power storage for home energy systems or even smaller applications such as e-bike batteries, we are able to greatly reduce the cost and environmental effects of these products.
To test this concept, we started on a smaller scale, portable power banks for electronics charging. We put together 3 prototypes to investigate the viability of this idea.
Our first prototype was a CAD model which outlined the general purpose of our device and served as a proof of concept for our solution. We used this model to analyze different layouts and their capabilities in handling high temperatures using a simulation. From this, we decided to use phase change materials in between the batteries to absorb heat and incorporated air channels for better cooling.
Our next prototype was a smaller version of our model, allowing us to rapidly print, test, and iterate our solution. This prototype's main focus is on the fitment of our device's components. This includes the batteries themselves and the circuit board which regulates charging. Due to the emphasis on integration between components, this design would end up having the highest fidelity, serving as a basis for future iteration and prototyping.
The third prototype was a circuit designed to test the reliability and safety of disposable vape cells in a power bank. The 2 sizes of vapes we took batteries from included 1,000 and 1,500 milliamp cells. We used both sizes of cells in this prototype in a parallel circuit to show how we can harvest from a variety of vapes. The assembly process of the circuit proved that cells can be reused safely with no risk of damage when done properly. Fully assembled, the circuit can be used to power small electronics that accept a voltage of 3.7 volts.
In order to collect lithium batteries for our product, collection bins will be set up in high-traffic areas for ease of disposal by the public. Many vape stores allow you to return your used vapes. We can collect these vapes through collaboration with the stores.
Combining the 3 prototypes, we were able to make a proof of concept able to charge objects like this Bluetooth speaker.
The largest limitations of our solution is found in the extraction of the cells. This is a labor-intensive process, since vapes must be deconstructed and batteries must be evenly charged before use.
In a large-scale operation, an automated process should be considered to reduce the time and cost of creating our product.
In conclusion, our project shows that disposable vapes don't have to become disposable waste. Even though millions are thrown out every day, their lithium batteries still have value, and by reusing them, we can reduce environmental harm while creating more affordable energy solutions.